The problem statement is that in southeast Utah, there are beautiful geologic features, parks, forests, and a variety of other sites. But in addition, there's historical to active uranium mines and mills that are potentially contaminating water resources. This is a photograph that I took in Moab at Arches National Park, looking past some of the geologic features and into the Sal Mountains. Our approach is to focus on San Juan County, Utah. The stakeholders include tribes, federal, state, and local governmental resource managers, industry, consultants, non-governmental organizations, and members of the public. The areas we're particularly focused on have had uranium mineralization, mining, and milling. We're comparing methods of defining background and baseline water quality, looking at the San Juan River watershed, Cottonwood Wash that flows into the San Juan River, various seeps and groundwater, and several aquifers. We're focused on compiling reports and data on historical pre-operations to site closure. Rock, soils, water samples, surface water, seeps, and groundwater data will be collected, and in addition, we're proposing to collect additional new data. And we want to evaluate regional water quality for site assessments and future remediation, and publish compilations of data reports and interpretations. I should mention also that we are in collaboration with the U.S. Geological Survey. You'll see several references to our work with USGS, and we are excited with the collaboration working together. And we're also looking for other partners to join us in this effort. This is a publication from 2020 by the Utah Geological Survey, Circular 129, where they listed the critical minerals in Utah, and uranium and vanadium are both listed as federal critical minerals, and the large number of deposits are in southeast Utah. And you can see the different colors, red, green, and blue, with red being major past producing mining districts, and, such as Lisbon Valley Mining District, and there's moderate past producers and minor producers as well, but very rich uranium deposits. And as a result of all the uranium mines that have occurred, starting really in the 1950s and 60s were the heyday, kind of ending more in the 70s and 80s. There, as a result, have been several uranium mill sites that have been created, but the only active mill site is at White Mesa Mill near Blanding, Utah. This is a map of the Four Corners region showing the boundaries of the Ute Mountain Ute tribe. And there's a small community at White Mesa, just south of Blanding and close to the White Mesa Mill. You can also see on this map Cottonwood Wash that flows to the west of Blanding down to the San Juan River, entering at Bluff. And the San Juan River flows from east to west. And then you can also see some of the other features in the area. This map also shows Monticello. There had been a uranium mill that's currently under the Environmental Protection Agency jurisdiction and managed by the Department of Energy. So in addition to the active uranium mill at Blanding, there's also historical mills such as Monticello and other locations. Mexican Hat also has a mill, as does Shiprock, New Mexico, and other locations, and quite a few in Colorado. This is San Juan County in Utah. Just really wanted to show the variety of land ownership from the Monte La Salle National Forest. There's a large amount of Bureau of Land Management, tribal land, private land, and so there's a lot of different stakeholders involved. This is a picture of Cottonwood Wash taken in December of 2002, which comprises 143,000 acres of the watershed, and there's joint ownership, as I mentioned. Cottonwood Wash flows when it's it's a arroyo, but it is comprised of like 60% goes to Forest Service land, 33% across the Bureau of Land Management land, 4% state of Utah, and 3% Ute Mountain Ute Tribe. You can kind of get a sense of the size of those channels and how much water would be flowing under major stream events that might only occur, you know, very infrequently, but when water does flow through there, it can be quite a torrent. This is a picture of an old uranium mine site, mine portal that was probably built in the 1950s or 60s time frame. And Bureau of Land Management came in and did their reclamation program at this location in 2002. They installed this bat gate. So the bats had established nesting habitat after the mining had ceased, probably in the 1970s. And then a lot of these open portals were subject to people going into their area, and a lot of radon gas comes out. So it's a dangerous area. And so the Department of Energy has more recently been going in, and I had worked on the drum, what's called the drum program for DOE, to assess over 4,000 uranium mines in the United States. And that program is out to relocate the mine sites that had stopped production in 1970, doing verification, validation, collecting samples. And so we would be collecting, gathering that information that's being collected by the federal government as well as part of the study. This is a picture of the White Mesa uranium and vanadium mill. And it's just 3 miles from the Ute Mountain Ute White Mesa community. And as I said, it's the only operating conventional mill in the United States, owned by and operated Energy Fuels, a Canadian corporation. And I put the link in there just to give a shout out for this picture that came from the Grand Canyon Trust website. This is a diagram of the geologic formations and aquifers in the area. The three major aquifers are the D, the M, and the N. So the D is the Dakota Sandstone and Burrow Canyon Formation. The M is Morrison Formation, and N gets its designation from the Navajo Sandstone, but it comprises other sandstones and formations as well. And so you can see that there's water that's obtained beneath the Manco Shale, and a potable water supply for a variety of purposes are using that water. So our key questions that we're presenting in this talk and proposing to talk about in future work is: why is defining background water quality important, and how is it defined? How well can background water quality be used to determine remediation goals? How is defining baseline water quality different than defining background? And will they change with climate or other threats? And can examining regional San Juan Basin background water quality be used to support local compliance assessments, which is the title of this overall talk. Our related project experience includes Colin Larrick, currently working on Ute Mountain Ute tribal water quality issues. Tony Ranalli worked with the USGS on the White Mesa Mill project and other uranium mining and mill site projects, and he currently works as a consultant. And we've worked together on a variety of projects when I was with Department of Energy. And my 1995 USGS study of the San Juan Basin in New Mexico is being used for as a background study by the Ute Mountain Ute tribe for the White Mesa Mill, which I was surprised to kind of discover online. Not being associated with this project at all, I found that report was available and on a website talking about the mill and the compliance report, and I thought, hey, that's really interesting. So we've been talking and proposing to do this work together. And I had previously worked for Department of Energy on a variety of uranium mills and abandoned mine sites. So this is a cover page of that USGS report I mentioned, done in 1995, called Geochemistry of Groundwater in the Gallup, Dakota, and Morrison Aquifer, San Juan Basin, New Mexico. And it's always nice to see when people are using your work. I kind of thought this had been long done and shelved. I started the project in 1985, did a 5-year study that was contribution of the Regional Aquifer Systems Analysis Program, where we looked at 10 aquifers and my focus for the geochemical study was just to look at the 3 aquifers, but it's always nice to know that people are using the work and that it's useful, it has a future use. So this shows the San Juan Basin structural groundwater flow and how generally everything's flowing from the center of the basin outskirts, and the older rocks are at the edge of the basin and younger rocks in the layer cake geology basin to the center. And quite a few flow paths go to the San Juan River. So I selected a major flow path that goes from the Chusca Mountains, collected water samples at Sonosti, all the way down to the San Juan River at Shiprock, and we'll show you some results of that. But the flow path analysis shows how water chemistry changes with distance. And this is a diagram showing water chemistry in the Dakota aquifer, and just a few wells were available. You can see quite a dramatic change between near the outcrop shown by the little lines and down by Shiprock that has much higher sodium and sulfate concentrations. And here's another one from the Morrison Formation that I was able to collect a lot more water samples. Actually, these wells originally a lot of wells were drilled for uranium exploration. They were flowing artesian wells, and quite a few open hole wells across those horizons. And the near the outcrop, the water quality was very pure, pristine water. And what we found was that very ancient Pleistocene recharge, older than 10,000 years old, existed not far from the recharge area. And as the water flowed towards the San Juan River, it increased in concentration, largely due to deep brines beneath the Morrison Formation that were flowing up into the basin and discharging in the San Juan River, increasing tremendously large increases in sodium and sulfate. So as I mentioned, I was surprised that this is being used because there were no regional studies in the Blanding area. This shows that a local study in Blanding, but no San Juan County wide studies have been done to date, and that's what we're proposing to do. So this is useful to show for the Blanding area in the Dakota Burrow Canyon aquifer that water flows from generally from north to south. And there's water chemistry data available that we'll be compiling for Blanding and for the other communities. So our goal is in defining local and regional background water quality is to determine if human activities have affected down gradient water quality and to establish remediation goals for future cleanup. We're going to look at upgradient monitoring wells that are upgrading at various sites, and we're also looking at intra-well comparisons of, say, a particular compliance well to its historical background. So there's a variety of ways of defining background. We're going to look at the different ways, as well as there's various ways of defining baseline, which is a set of conditions that describe water quality conditions or processes as they exist today, and will serve as the point of comparison to determine future changes and trends in such as effects of climate. And one way to do that is to look at the upgradient wells and define the 50th percentile as the value that is compared to increases that might be as a result of the impact from a site. And another way to define it is look at all the data for upgradient and downgradient wells, and then select a certain percentage. It could be 90% or more, where you're just looking at a narrow range of constituents and you're saying, this is what we think a better value for baseline would be. So we're seeking grant funding and additional partnerships to do a couple studies where you're looking at building hydrologic biogeochemical model for loading, looking at primarily uranium and gross alpha, but we'd be collecting as much information as we can as water flows from Cottonwood Wash through the legacy mine areas to San Juan River. And also we want to do a background regional study looking at water quality trends and multiple formations, surface water, aquifers, to look at current conditions and prior uranium-vanadium, before additional mining occurs, or looking at past mining impacts, looking at reclamation, and before reclamation is established or goes forward, and trying to look at there's going to be expanding of the White Mesa mill operations and impacts from climate change that will also degrade water quality. So that's my talk. That's our presentation, and thanks for your participation.